Hi everyone, welcome you all to SRM Madurai College for Engineering and Technology Channel. This is Divya Bharathi from Department of Information Technology. Today we are going to see the subject Theory of Computation. Under Finite Automata concept, we are going to see the important title named Conversion of NFA to DFA. Before entering into this particular title, I would like to explain a little bit about finite automata and types of finite automata. Finite automatas are abstract machines which is used to recognize patterns in input sequences, forming the basis for understanding regular languages in computer science. These consist of states, transitions, and input symbols, which are processing each symbol step by step. If the machine ends with an accepting state after processing the input, it is accepted state. Otherwise, it will be considered as a rejected state. Finite automata comes in two types, which is deterministic finite automata and non-deterministic finite automata, both of which can be recognized the same set of regular languages. The finite automata which accepts the regular languages. They are widely used in text processing, compilers, and network protocols. Deterministic finite automata. DFA consists of five tuples, in that the capital Q represents a set of all states, and this alphabet symbol, which is set of input symbol, it may be 0, 1 or A, B alphabets, and the small q represents the initial state, it may be the starting state of a machine. Then F, which is represents the final state of the transition. The transition, here the transition function is defined as the transition of set of all states multiplied with the input symbol. So here, let us consider an example. Consider a DFA that accepts all the strings ending with A. Here we have to design a deterministic finite automata which should end with A. So consider this as Q naught as an initial state and Q1 as a final state. So while representing the initial state, we have to mark as this arrow as an initial representation of initial state. So mind the thing that the final state which is accepting the input, it should be entered with the A. Here what our question says that the DFA which accepts all the strings that should be entered with A. So that's why we have given here the Q naught using the input A, which is transits to the final state, and it is a self loop, that is the Q1 using the input A, that is also transits to final state. As we seen in the previous slide, the DFA says that the input should be accepted by the finite automata only it reaches the finite state. So let us consider with an example. Check whether the given string is accepted by the DFA. So here the string has been ended with the A. So for this only we have drawn this diagram. So how we have to check this, whether the string has been accepted by the finite automata. The only condition is that the string which is accepted by the finite automata only when it reaches the final state. So let's we check with an example, that is what is the starting state here, Q naught. So Q naught comma, we have to write the string A, B, B, A. Okay. So next we go with the transition function. So what is Q naught comma A? Q naught state using the symbol A transits to Q1. So we have to replace with the Q1 comma, we have to write the remaining alphabets, that is B, B, A. So then transition of Q1 comma B. What is Q1 comma B? So here Q1 using B, it transits to Q naught. So we have to write Q naught here, and we have to write the remaining string as B, A. So then what next? We have to check with the Q naught comma B. So Q naught using the input B, it transits to the self state, that is Q naught itself. So transition of Q naught comma A. So what will be the Q naught comma A? Q naught comma A, which is Q1. So at last we reached the final state. When we reach the final state, the given string is accepted by the finite automata. So let us consider that what the diagram is drawn by us is correct. Here I have given the transition table for the particular transition diagram. Here I have written as the Q0 using A input, it transits to Q1, and the Q0 using the input B, it transits to self loop, and Q1 using the input A transits to self loop, and Q1 using the input B transits to Q0. Let's see about non-deterministic finite automata. NFA is most similar to DFA with including the following features. First one, it can transition to multiple states for same input. So while moving with the DFA, the single state using a single input, there is a transition of only one state. So in previous slide we have seen that, for example, Q0 using the input A, it transits to a single state which is DFA. Here, the same Q0 using the input A, it transits to Q0 as well as Q1. Here they have written as the Q0 using A, it transits to itself loop as well as transits to Q1. Here there is a multiple transaction. That's what here we are seeing that it can transition to multiple state for the same input. But here for the same input, there is a only one transition, that is what the DFA. This is what the major difference between the DFA and the NFA. And also it allows the null moves. The NFA allows null moves where the machine can change states without consuming any input. Without a single input, that with the null input, it can transit from one state to another state, which is considered as a non-deterministic finite automata. But in deterministic finite automata, there is no use of null moves, and also there is a single transition with the same input. This is what a very important features which is to be noted between the difference between the deterministic finite automata and non-deterministic finite automata. Here, see the example that here also for a same example, which is the input string should be entered with A. Okay, here also the same scenario, but we have drawn the NFA diagram. So here I have given the transition table with two states, that is Q0 and Q1. The Q0 using the input A, it transits to Q0 as well as Q1. So we have written in the set bracket. The set bracket is used only for the NFA transition table. So, and the Q0 using the input B, it transits to Q0 using Q0 using B transits to Q0 itself, and Q1 using A, there is no transitions. So we have to return as null function, and as a way Q1 using the input B, there is null transition. So here we have written as the null input. On to our topic, conversion of NFA to DFA. Here I have given the steps for converting the NFA to DFA diagram. Already we have seen the difference between the DFA and NFA. There is a two important difference between NFA and DFA. So here the question may be given with the NFA example, and with the following these steps we have to convert those example into DFA. This DFA in the sense we have to come up with the transition diagram as well as transition table. So let's go on. Step number 1. First we have to convert the given NFA diagram to its equivalent transition table. So first of all we have to draw the transition table for the given NFA transition diagram. And step number 2, we have to create the DFA start state. So here we have to choose which is to be act as a start state for the DFA diagram, which is our resultant diagram, and we have to create the transition DFA transition table by following the procedures. This the and step number 4 is to create the DFA's final state. So very important thing is DFA start state and DFA final state and also DFA transition table. At last we have to draw the transition diagram of DFA. So we have to repeat the steps furthermore until we reach the simplifications. Okay. Consider the following NFA diagram which is shown in the figure 1. That is, here you have to know that set of states. So the set of states are Q0, Q1 and Q2. Here the initial state is Q0 and the final state is Q2. So we have to note that initial state is Q0. Q0 is initial state and Q2 is our final state. Okay. So here we have come up with the NFA diagram. So our main motto is to convert the NFA to DFA by following the steps which we have seen in the previous slide. So step number 1 is to find the transition function of the given NFA. So already we have seen the procedure how to find the transition function for the NFA. So just we have to go initiate with the initial state that is Q0. Q0 using the input A, it transitions to Q0 using A transitions to Q0 as well as the Q0 using the A input A, it transitions to Q1 also because it is a NFA diagram. So it may be possible. So using a single input, there may be a multiple transaction in NFA. So likewise, we got an example. So Q0 using B, it answers to Q0 itself and Q1 with the help of input A, there is no transaction. So we have to mention as null symbol and Q0 using the input B, there is a transaction to Q2. So the Q2, there is no transaction with the help of any input. So we have to mention it with the by state. Create the DFA start state. DFA start state should be equivalent to NFA start state, where we have seen in the very previous slide that start symbol should be Q0 and the transition of the input using A is Q0, Q1 and B is Q0. The only difference we have done here is here we have changed the set bracket into square bracket. Why? Because in set bracket it should be considered as various multiple state, but in DFA it is not possible for multiple state using a single input, so that we have considered the Q0 Q1 state as a single state. That's why we have used the square bracket. So consider this Q0 Q1 as new state. So this is what the new state for the DFA. So initial state should be as like the NFA, and step 3 is we have to create the DFA transition table for the new state. So no new state here is Q0 and Q1. With this, we have to create the DFA transition table. It is Q0, Q1 transition of using the input A, naming a transition of Q0 comma A, union transition of Q1 comma A. So transition of Q0 comma A, already we know that Q0 Q1 and Q1 using A, there is null symbol. So the union value will be Q0 Q1. So we have written as Q0 Q1 here, which is also written inside the square bracket. And next one, we have to find the state for the input symbol using B. So transition of Q0 Q1 using the input B. So we have to find transition of Q0 comma B union transition of Q1 comma B. For reference, I will show you the question diagram now. Here I have drawn the question diagram. So now check with this diagram and write the result. Transition of Q0 B is Q0 and transition of Q1 base Q2. The result will be Q0 Q2, which is also new state. So we have to write Q0 Q2. So the resultant value for input A is Q0 Q1, which is a previous state. Already we have written that. And this one is Q0 Q2, which is a new state. So here I have mentioned that, and we have to create the another transition table for the new state, that is Q0 Q2. So once again we have to check over with the input A, and once again we have to check over with the input B. Repeat the same step again for creating the DFA's transition states. So we have to decide that it should be final state or yet to be followed. Repeat the procedures. So here our new state is Q0 and Q2. If like this again and again, if the new states arrivals, we have to repeat the following procedures again and again. So let's see for the states Q0, Q2 using the input A. So Q0 using the input A union Q0 Q2 using the input A. As per the diagram of NFA, Q0 using A is Q0 Q1 and Q2 using A, there is no transaction in the Q2 state. So while performing the union operation, we may get the Q0 Q1, which is the old state. So we have to stop the procedures. We have to check with the new state Q0 Q2 with the input B, Q0 using B, which is Q0, and Q2B, which is null. So here we get Q0, which is also old state. Now let's draw the DFA diagram with the help of the created DFA transition table. So here starting state will be Q0. So we have to represent with this arrow. So the Q0 using the input, it changes to the state Q0 Q1, and Q0 using B, it changes to the self loop, and Q0 Q1, it changes to the self loop using the input A, and using B, it changes to Q0 Q2. In DFA diagram, Q2 is considered as a final state. So the Q2 is appeared in the state, so which is considered as a final state in DFA. So Q0 Q2 using the input A, it changes to Q0 Q1, and using B, it changes to Q0 itself. This is what our DFA diagram. Let's check whether it is a DFA diagram. Our DFA diagram condition is that the state using the single input, it should be changes to only a single state. There is no need of multiple transaction in DFA. So the NFA only with the multiple transaction, the DFA is accepted only there is a single transaction with a single input. So likewise we have to check Q0 using B, there is a single transition. Q2 using A, there is a single transition. Q0 Q1 using A, there is a single transition, and using B, there is a single transition, and Q0 Q2 using A, there is a single transition, and using B, there is a single transition. This is what the DFA diagram for the given relevant NFA. Understand? For further queries, contact my mail ID is on here. Thank you. Thank you for watching this video.